Hello everyone. In this video, we will see definition of complex number. But before that, let us see what is I. So I is called as imaginary number which we are using to denote root of minus 1. So the value of I is root of minus 1. Now let us see some powers of I or how to find out powers of I. I square. So I square will turn out to be root of minus 1 square, which is nothing but minus 1. I cube we can find out using laws of indices by writing I cube as I square into I, which is nothing but minus 1 into I, that is minus I. Now let us see how to find out I raised to 4. I raised to 4 we can also write as I square into I square. If you want, you can also write I raised to 4 as I square the whole square. As we know that I square is nothing but minus 1, so this is minus 1 into minus 1, that will be 1. Similarly, if I want to find out in using this way, so this is nothing but minus 1 square, because we know that I square is minus 1. So this is equal to 1. So anyhow, you need to convert this I raised to 4 using laws of indices in some lesser power of I, so that you can easily find out any power of I. Let us try to find out I raised to 5. I raised to 5 I can write as I raised to 4 into I. Now I raised to 4 is 1. So the value of I raised to 5 is 1 into I, that is nothing but I. In this way we can find out any power of I. Now let us try to find out some higher power of I. Now let us find out I raised to 203. We will try to solve this also using laws of indices. So we will divide this 203 in two parts, but in such a way that one part of 203 will be a multiple of 4. So I can write down this 203 as I raised to 200 and I raised to 3. Obviously 200 plus 3 will turn out to be 203. So this is equal to, we know that 200 is a multiple of 4, and just because of that I can write it as I raised to 4 raised to 50. And I cube, we know that using this, let us say that it is 1. So using 1 we can say that I cube is minus I. So this is minus I. Why we are converting this 200 into the multiple of 4? Because we know that I raised to 4 is 1. So we can use this also. So we can use this. I raised to 4 is 1 raised to 50 and into minus I. So 1 raised to 50 is nothing but 1, and we have here into minus I. So the final answer will turn out to be minus I. So this we can solve using 1 and 2. So we can just say here from 1 and 2. From 1 and 2. So in this way you can find out any power of I. Now you try to find out I raised to 607 on the same basis. Now let us talk about a complex number. Complex number one can denote by Z. Small z basically. So small z is nothing but x plus iy, where x and y both are real numbers. And this I is imaginary number, we know that, and it is nothing but root of minus 1. Then set of complex number we are always denoting by capital C. It is in this way. So set of complex number we can denote by capital C, and any element of the set we are denoting by small z. So small z belongs to C, that means z is nothing but in the form of x plus iy, where x is the real part and y is called as imaginary part of z. So let us write this real part of z, which we can also denote by r of z, which is equals to x in this case. Similarly, imaginary part of z we can denote by I of z, or also img, that is imaginary part of z, which is nothing but y. So just remember, x is the real part and y is the imaginary part. So basically real part and imaginary part of z both are real numbers. So Whenever we are talking about imaginary part of z, we are not considering I here. It is simply y we are writing. Remember one thing, either we write x plus iy or we write x plus y into y. It is one and the same. Then the next thing that we will see here is what will happen with the number if I take imaginary part 0 and the real part 0. So if y is equals to 0 in our complex number, z is equals to x plus iy, then z is equals to x. That means z is nothing but a real number. So this implies z is real number. So whenever y is 0 or imaginary part 0, z is as good as a real number. What happens if we have x equal to 0? So if we are taking x equal to 0, we will get z is equals to iy. That implies z is purely imaginary number. So whenever in a complex number, if real part is 0, then that complex number is called as a purely imaginary number. Thank you.